Good afternoon to everyone. In the last session, we focused on how to find the prime factors of the given number. We have seen two methods. In this session, we focus on array operations, how to insert an element into the array, how to delete an element, and how to remove the duplicate elements, how to split the array, and how to merge the two arrays into a single array. This is our focusing. Hope you have gone through the last session. Have any doubts in the last session? If you have any doubts in the last session, please ask. Otherwise, we move on to the next topic, array operations. First, let's see how to insert an element into the existing unordered array at a particular location. First, to take this example, insert an element, insert an element into the array at a particular location. How to insert an element into the array at a particular location. Suppose the array consists of n elements, say a1, a2, a3, etc. an. We do want to insert an element at some jth index. Insert the specific index or a specific index called j. Let j pointing this index 1 less than or equal to j less than or equal to n. Suppose when j is pointing this index, already we have an element a of j. We need to insert a new element at a of j. So the logic is insert new element at a of j. Starting from a of j, elements are moved one bit position right direction. That means a of j plus 1 receives the value of a of j. Whatever we have current a of j, this is moved to j plus 1 location. That is the meaning. A of j is assigned to a of j plus 1. A of j plus 2 assigns the value of a of j plus 1. That means this j plus 1, this is moved one position right, etc. What is the last element? For example, a of n. A of n receives the value of a of n minus 1. Previous value is n minus 1. A of n receives value of a of n minus 1. Since one element is inserted, assuming that previous array size is n, after insertion, after insertion, array size becomes n plus 1. So the last element to be considered is a of n, that is actually moved to n plus 1th location in the array. So shall we write this way? A of n, this is assigned to the n plus 1th location in the array. This is the insertion procedure to insert an element at the jth index so that elements from jth indices are, that means a of j plus 1, a of n minus 1, etc., a of n are completely moved one position right direction. A of j to a of j plus 1, a of j plus 1 to a of j plus 2, etc. A of n is moved to the n plus 1th location in the array. This is the logic of array element insertion. Hope you understand. Now let us test this procedure with its implementation. Hash include stdio.h int main. What is expected? We need to define the array size. For example, int a of 50. Maximum 50 elements can be assigned into the array A. When we do insert operation, that stage actual array size is incremented by 1. So int a of 50 then have size. First let us input value of size. Printf slash n, enter the value of size. That means how many inputs we do want to consider. And percentage d ampersand size. Then let us input enter size values. Printf slash n, enter percentage d values. Percentage d is replaced with the variable size. Enter size values. Let us get these values through the for loop. Say for some I is equal to 0, I less than size, I plus plus, scanf percentage d ampersand size of I. So inputs to the array elements are completed using these for along with the scanf statement. Then we need to input the position where we do like to insert a new element. Enter the position or index to insert new element. Let us have write that position right as a new variable. Say scanf percentage d ampersand position. Assuming that position is a variable that determines the position where the new element is going to be inserted. And you need to input right another one new element position, or let's have the variable as value. Next, printf slash n, enter the value and or enter the new value to be inserted at, not necessarily new value, right? Even it may have the duplicate values. Okay, enter the value to be inserted at percentage %d, comma, replace the variable position and get this input through the scanf statement, scanf percentage %d ampersand value. So we have obtained the new value, right, and the corresponding position. Next, we need to consider this insertion process. Before assigning the value to the jth location or the location, right, position into the array, we need to move the elements from position to the last value. So how do we achieve this? How do we achieve this operation? This one, a of j plus 1 is a of j plus 2 is a of j plus 1, etc. A of n plus 1 is a of n. This can be achieved through a for loop. So can you tell me how do we construct a for loop? What is this j here? J plus 1, etc. n minus 1, n. So this j is nothing but the new index at which the element is going to be inserted. In our example, right, we have the position. So for some variable, right, we can take a of j plus 1, a of n minus 1, a of n, right? This can be the value at j plus 1, etc. n minus 1 and n location. So I use the variable j, for example, j is equal to position, comma, j less than what is the last value, that is size, then j plus plus. Here what we have to do, suppose array index starts at 0, 0, 1, 2. So that stage, okay, j is position. We need to think of first position, second position, etc. So if we start, j is equal to position minus 1. Let us have position minus 1. J less than size, j plus plus. We need to convert this into the algorithm. A of j plus 1 is equal to a of j. A of j plus 2 is equal to a of j plus 1. A of j plus 1. A of j plus 1. We can write as it is a array name j plus 1. This is equal to a of j. That's all. Initial value of j is position minus 1. So a of position minus 1 plus 1, that is equal to a of j, a of position minus 1, etc. Last value a of j is size minus 1, a of size, that receives the value of a of size minus 1. Then we need to update the new location. What is a new location? J is incremented by 1. Let's write a of j is equal to the new element is value. Let's print the result after insertion. Print after insertion. operation. Let us print the values for I is equal to 0, I less than size plus 1, I plus plus printf slash n or slash p after insertion. Yeah, printf slash p percentage d comma. What is our array? A is the array name, A of I. That's all. Then return to 0. Let us test the code. Save the file as file cp88 f2 okay f9 one error. I think position value I j. What is missing? Scanner percentage d ampersand. What is this one? Array name. Array name is A. So modify here. It's not size of I. Enter percentage d values. Array name is A. So here write this is A of I. Okay. F9. Program has been successfully compiled. Enter the value of size. For example, 5 values we are going to give. Enter 5 values. Say 1, 2, 3, 4, 5. Not necessarily the values are in ascending order. Can have right any combination. Enter the position or index to insert the new element. For example, in the third position, I do want to insert a new element. Enter the value to be inserted at position 3 actually, at position 3. At position 3, I do like to insert a value, say -1. Pressing enter, what happens? After insertion, the result it seems 1, 2, 3, 3, 3, 3, -1. So we have inserted -1 at the end, but actually at position, right, we need to insert a new value. So how do we write the code here? Not A of j is equal to value, A of position, this is equal to value. Value is inserted into the specific position. Checking again, enter 5 values 1, 2, 3, 4, 5. For example, the third position, the element to be inserted at third position is -1. Are you getting the correct result? 1, 2, 3, -1, 3, 5. So position 3, for example, here if I mean first one is 0th position, then first position, second position, then at the third position, -1. This is okay. But 1, 2, 3, -1, what we have to get? 4, 5 is expected. 1, 2, 3, -1, 4, 5. So what are the changes to be made? What are the changes to be made here? 1, 2, 3, 4, 5. Suppose 0th position, first position, second position, the third position. Third position means here write the value at fourth, right? That place -1 is inserted. That's good. Then two more values will be 4 and 5. But we are getting the incorrect result. A of j plus 1 is equal to A of j. How do we modify this? Any idea?
Sir,
How
I
do we
had an
construct a
internet
logic
issue.
here?
Can you repeat the question, sir?
Actually, we mean third position means assuming that the index starts at 0, 0, 1, 2, 3, 4, 5, etc. Input elements
Sir?
are 1, 2, 3, 4, 5. Input elements are 1, 2, 3, 4, 5. We are going to insert the new element at third position. In case if you assume the index starts at 0, 0, 1, 2, 3. So third means here the value pointing fourth one. That 4 is replaced at a new value -1. That is correct. Following that, we have got 3, 3 as incorrect result. So how do we change? That 3, 3 should be changed into 4 and 5.
Sir, maybe we can initialize a new array and save the elements after that position in that temporarily. And after insertion, we can return it back to the original array, sir. Like that, we can do.
A good question, a good answer, right? There is one possible solution without any temporary array.
So maybe a temporary variable, sir.
Temporary variable. We have to look into right this operation. A of j to A of j plus 1, A of j plus 2 to A of j plus 1, A
Sir,
of n that assigns A of n minus 1. That should be think, right? You need to think of that one.
sir,
Hmm.
sir, in the for loop, instead of giving j less than size, can we give j less than position?
J less than position. Why? J starts at a position -1 up to last index. Last index is size -1. So position -1 to last one. Size -1. That's correct. So let us have j is equal to position -1. J less than size. J plus plus. A of j plus 1 is equal to A of j. Let us check it again. Control F9. Size is 5. 5 values 1, 2, 3, 4, 5. Third element is -1. Again it shows 1, 2, 3, -1. Say at third position. Third means here fourth position. It's inserted. Then it shows minus plus 3 and plus 3. How do we change that into a 4 and a 5? Can you think of this one again? A of j is moved to A of j plus 1. Then A of j plus 1 is moved to A of j plus 2. A of n is moved to A of n plus 1. The problem with this assignment is, once, please think here, when I mark here, please understand, when A of j is moved to A of j plus 1, A of j plus 1 assigns the correct value. Then this update is taken here. So this update is again assigned to A of j plus 2. So whatever you are having A of j, the value is subsequently assigned to all locations. Hope you understand. Understand or not? Say yes or no. That's what the result is, 1, 2, 3 minus 1. Then you are getting the
Yes, sir.
number
Clear,
of
sir.
locations. Yeah, very good. So that's what, right? The same 3 is placed in all subsequent locations. So what is the solution? Can you think of? This question is left to you. The same operations, okay, I tell you the solution. The same operation, if we write this way in the reverse order, for example, here A of n plus 1 is equal to A of n, then A of n is equal to A of n minus 1, etc. Say A of j plus 1 is equal to A of j. If we write, what happens? First nth location is assigned to n plus 1th value. No problem. Then whatever your value n minus 1th location, that is moved one position right, nth location. Hope you understand. Let's see this example. 1, 2, 3, 4, 5. Assuming, right, this location, we do like to insert minus 1. 1, 2, 3. You need to mark this location. So what is a simple procedure? First, move, right, this 5 into the next location. For example, this is 5. Move 4 into, right, the next location. This is 4. Move this 3 into its next location. Here we will get, or you are finding the correct position. Okay. This is a place where you need to insert. So 3 is kept as it is. This is actually pointing, right, this 4th one. So once the 4 is moved to the next location, here insert this new element. Insert this new element so that we will get the outcome 1, 2, 3, minus 1, 4, 5 as the correct insertion. Understand or not? Understand the logic?
Yes, sir.
So for loop should be written in the reverse order. If you write the for loop in the forward order, you will get the same result in all locations. So in the reverse order means, just think of A of n plus 1, then A of n, A of j plus 1. So using this for loop, A of n plus 1, A of n, A of j plus 1, we are writing the control variable which ranges from this one, n plus 1, n, j plus 1, in the reverse order. This should be returned first. So how do we modify the control variable for j is equal to n plus 1? What is n plus 1? n is n represents the number of elements. Say, let us start j as size plus 1. J is equal to size plus 1. Then a of j plus 1, that is a final value. So if we keep j less than size, this should be changed to j greater than position j plus plus, this should be changed to j minus minus, greater than or equal to, right? That we can check it. A of n plus 1 is equal to a of n. A of n plus 1. N means, right, current j. So if you write a of n plus 1, a of j plus 1, this is equal to a of j. A of n is equal to a of n minus 1. For the next value of j, we will get a of n is equal to a of n minus 1. So let us check this code in the 9. Enter the size 5. 5 values 1, 2, 3, 4, 5. Enter the position, say third position. Element to be inserted as minus 1. 1, 2, 3, minus 1. Again we have the repetition of last element, 5, 5. So what we have to do? How do we modify this logic?
Sir,
Or yes, tell me.
sir, the array size is 15, no, sir.
Yeah.
So we can do it like the element in A5 will move to A6 and then A4 to A5. Like in the from last will go to the required position. Maybe then it won't repeat, sir. Then
So that's what we have moved from right to left. J is equal to size plus 1. J greater than position. J minus minus. A of j plus 1 is equal to A of j. A of j plus 1 is equal to A of j. What happens? How to modify? Simply start j at size. J is equal to size. J greater than position. J minus minus. Have A of j plus 1 is equal to A of j. Let us trace and find. Process is already running. Control F9. Enter the size, for example 5. 1, 2, 3, 4, 5. Third location minus 1. 1, 2, 3, minus 1. But we expected 1, 2, 3, minus 1, 4, 5.
J is equal to size minus 1 or
Louder, please.
J is equal to size minus 1.
J is equal to size minus 1. Then
Yes, sir. So here also A of J minus 1 is equal to A of J.
A of J minus 1 is equal to
A of J.
A of J. Let's check it. 5, 1, 2, 3, 4, 5. Third, minus 1. 1, 2, 3, minus
Position
1,
minus
5.
1.
Hmm? J greater than
A of position minus 1.
A of
Position minus 1.
position minus 1. That's incorrect logic. A of position is value. You cannot change position minus 1. That's incorrect logic. Let's check now. 1, 1, 2, 3, 4, 5. Third, minus 1. What happens? 1, 2, 3 is third location. 0, 1, 2, 3. That is inserted as minus 1. Then 4, 5. You got the result. Let's check for some other cases. Control F9. Enter the size 5. 5 values 1, 2, 3, 4, 5. Suppose second location minus 1. 1, 2, that means 0, 1, 2, minus 1, 3, 4, 5. This is correct. Let's check for first location. Enter the array size, for example, 3, 10, 20, 12. Enter the location, say first location. I do like insert minus 25, 0, 1, right? So location is minus 25. Location is right 1, 0, 1, 10, minus 25, 20, 12. This is correct. In case if I put control F9, array size is 3, 100, 40, 20, 0th element, enter the value to be inserted at 0th element, suppose minus 100, minus 100, 10, 40, 20. Then at the boundary, control F9, array size is 3, 3 values 10, 40, say minus 100, enter the position 0, 1, 2, I mean the second index. Second index, I do like to insert 500. 10, 40, 0, 1, second index. Minus 500 is changed to minus 100 is changed to 500. That's all. Minus 100 is moved to next location. Are you clear? This is what I have expected from you. J is equal to size. There is no change because here A of n plus 1, n is actually the size. So if you write J is equal to size, writing A of n plus 1 is equal to A of n means next stage A of n is receiving a value A of n minus 1. You are getting the same result from right to left until you reach the position. So instead, I write A of j as A of j minus 1. That decrement operation is performed in the right hand side, so that for each value of j, right hand side is pointing A of j minus 1th value. So A of j minus 1th value is moved to jth position. So that's what we need to write A of j is equal to A of j minus 1, so that j ranges from size plus 1, size plus 2, etc. up to position minus 1. In the reverse order, j minus 1th element is moved to jth location. Finally, the position value at the position is set as A of position is equal to value. So here logically give enter the position index to insert a new element, the range right index range 0 to size minus 1, 0 to, or I write percentage b, here I write comma size minus 1. That's all. Control F9, enter the value of size, say 7. Enter 7 values 10, 45, 89, 90, minus 25, 1, 2, 3, 4, 5, 8, 80, 80, say 1000. 7 values here, 80. Now enter the position index that we mean 0 to 6, because size is 7. So I mean index right 0 to 6. First index right 10, second index or 0th index 10, first index 45, second index 89, third index 90, fourth index minus 25, fifth index 80, sixth index 1000. So you need to input the position value in between 0 to 6. For example, I input 5. The new element to be inserted at fifth location is say 777. Pressing enter, fifth location 0, 1, 2, 3, 4, 5. So this 80 is changed to 777. So 10, 45, 89, 90 minus 25. After that 777 is output here. Then 80 and 100, so 80 and 1000 are moved one position right. This can be achieved using our for loop. So in the for loop, we have designed the logic. Jth location is always assigning a value from j minus 1th location. The problematic stage that we have had right in the previous logic is A of j plus 1 is equal to A of j. That means the value of A of j is always assigned to A of j plus 1. So that right side values are always assigned till reaching the position. But if you decrement the position j minus 1 in the right hand side, ultimately for each value of g, its previous array element is assigned. So A of j is assigning the previous array element, so that you will not get any incorrect result. So this is the logic to insert an element into the existing array. Even you can insert the duplicate values. For example, consider this run. Control F9. Enter the array size, say 7. 7 values 10, 20, 30, 30, 30, 40, 50. 1, 2, 3, 4, 5, 6, 7. 7 values. Suppose the index is 0, 1, 2, 3. Third index. New element to be inserted at the third index is again 30. So how it changes? 10, no change, 0, 1, 2, 3. That means the second 30. Second 30 is replaced to again the same value 30. So starting from second 30, the values are moved one position right, starting from the second 30. So after this second 30 in our output, next you have this movement 30, 30, 40, 50. So you have 30, 30, 40, 50 after the second 30 in the output. This is the logic. Understand? Have any doubts? We didn't use any temporary array. Temporary array is not required. Vasudhaji and others got it?
Yes, sir.
Likewise, the next exercise is this one. Array element, right? Deletion. This is inserting an array element at position or at index j. Next, we need to devise a logic to delete an array element at a particular index.
Sir, the
Suppose-
same for loop can be applied, sir. Instead of
Yeah,
accepting,
same for loop can be applied. The same for loop can be applied. We need to make a little bit change in the assignment statement. Let me complete right with an example.
So we can give /0, right?
What on? Deletion of an element. Since these are static size arrays, we are not able to delete a particular location in the array, but we can rearrange the array elements and we can reduce the size by 1. Initial size is, for example, size. After deletion, at a particular position, say at position, for example, its range is 0 to size minus 1. How we have inserted an array element in between the indices 0 to size minus 1. In the same way, here we are going to perform the deletion operation in between the indices 0 and size minus 1. So after deletion, number of array elements, size gets updated to size minus 1. For example, n is equal to 5. 8, 2, 5, 9, 10. Assuming the indices are here 0, 1, 2, 3, 4. Suppose position is 2. What it points? It points position 2, index 2. Value at index 2. Value at index 2 is this 5. This should be deleted. So during the deletion, we need to move the elements left to right. So first 9 is moved to the deleted position. So after deletion, the expected output is 8, 2, 9, 10. In this case, initial array size, this is size is 5. After deletion, size is 4. 4 elements, that means first 4 elements are going to be printed. Even Fifth location, right, we have the same quantity 10, but we need to consider only size minus 1 elements. This is the deletion. So during the deletion process, you need to get same thing. What is the position to delete? And what is the only right one thing, right? What is the position, right, to be deleted? Value, right, need not be obtained because this is deletion. Insertion means index, location or position is required and the corresponding value is required. In deletion, just index or position is enough. Getting the position value, we need to consider starting from position plus 1. Let us devise a logic right here. From the example, suppose n is equal to 6, 8, 2, 5, 3, 7, 10, having 10 elements. Sorry, 6 elements. Having 6 elements. Indices are 0, 1, 2, 3, 4, 5. Suppose we input position is equal to 4 or position is equal to 3. Position is equal to 3. This 3 is pointing this 1. So target is this 3. This is actually pointed by the variable position. We mean this index. These are indices or subscripts. So expected output is eight, 2, 5. This 3 should be deleted. If we delete this 3, that means this value, this is going to be deleted. We need to move this way. This 7 should be moved to this A of position. That means 8 to 5, 7 should be reaching the previous position. Likewise, this 10 should be moving to its previous position. Actually, the 7 is moving to this location. 10 is moving to the previous location. This is the expected output. So to devise this, what we have to do? What is the logic to implement this deletion operation? In expected output, we need to print only 0 to size minus 1 elements. This is very important. 0, right? This is 0, 1, 2, 3, 4. How many elements we need to get? 0 to size minus 1. Size is right 6. 6 means here actual n, right? This is n, which represents size. Size is 6. Actually, 6 minus 1 is the last location. So we need to access the first size minus 2 elements. 6 minus 2. 4 elements. 0, 1, 2, 3, 4. Last index is 4. First index is 0. So size minus 2 plus 1 for the 0th element. Totally size minus 2 plus 1. That results in size minus 1 elements. Any logic?
sir, can you repeat the question, sir? நடுவுல விட்டு விட்டு
Just to
கேட்டுச்சு.
have this example, yeah, n is equal to 6. Having these 6 values, say 8, 2, 5, 3, 7, 10. Index starts at 0, 0, 1, 2, 3, 4, 5. So you can input the position value in between 0 to size minus 1. That means 0 to size minus 1. 5 minus 6 minus 1, 5. In between 0 and 5, you can input any index. 0 means this 8 is deleted. 5 means this 10 is deleted. Suppose position is 3. 0, 0, 1, 2, 3. This is the target. This element, that means value at this index 3 should be deleted. So after this deletion, 7 should be moved to previous location. 10 should be moved to a previous location. So we need to traverse from left to right until reaching the position. So once you reach the position, the required assignment is starting from position, next location is position plus 1, etc. Last location, what is its last value? 5. 5 is controlled through the array size.
Size minus 1, sir.
Size minus 1. Yeah, very good. Size minus 1. So in the for loop, you need to consider these range. Range means, right, starting value, position, last value, size minus 1. This is a range of for to be considered. Just have a look into this one. 7 is assigned to the previous location. What is this 7 in terms of position? This is position plus 1. Or shall we write this way? A of position is equal to, what to write? A of
Position plus 1, sir.
very good. A of position plus 1. That should be in array subscript. So I write in the next line to avoid the confusion. A of position plus 1. Plus 1 should be mentioned, right, as an index part. So here position is what one? 3. So first value of position is 3. 3 means A of 3 is equal to A of 3 plus 1. 3 plus 1 is A of 4. So A of 4 is directly assigned to A of 3. So A of 3, this receives a value 7. This one. A of 3 receives the value of A of 4, that is 7. Then the next value of J, for example, in the for loop, position plus 1. Current position is 3. That is A of 3 is equal to A of 4. A of position plus 1. 3 plus 1. A of 3 plus 1. That is A of 4 is equal to A of position plus 1. That means position is, right, currently 4. 4 plus 1, what happens? 5. A of 4 receives the value of A of 5. A of 5 is 10. This 10 is updated to the 4th location in the array. So how long you need to continue the process until the new index value or last index value, this one, reaches yes, tell me, till it reaches
Till size minus 1, sir.
size minus 2. because size is 6. This index is 6 minus 2, 4. If you put size minus 1, you will be reaching
Yes,
again
sir, yes,
right
sir.
10.
Ah.
That means the fifth index. So carefully write in our assumption 0 to size minus 1. This is the possible value of position. Final value of position is not size minus 1. This should be updated to size minus 2. So finally, A of position is equal to A of position plus 1. That is A of size minus 2. A of size minus 2 is A of 6 minus 2, that is A of 4. A of 4 is equal to A of position plus 1. That means position is right 4 plus 1 5. That's all. So what you
Yes,
have to
sir.
do,
Yes, sir.
you try to write implement this deletion logic in C program. So try to implement right this highlighted logic starting from position, last value of control variable, for example j is size minus 2. Simply write A of position, or you can write A of I is equal to A of I plus 1. That's all, where initial value of I is position. So you try to write implement this deletion logic and check if you have obtained right the correct result. Have any doubts? So these are array insertion and deletion operations. If you have
Sir?
any doubts, you can ask. Yes.
Sir, can you explain this again? The size minus 2.
Size minus 1. Actually, array index starts at 0. So the last index is size minus 1. In case once one element is deleted, last index is clearly size minus 2. This is a simple logic. For example, when n is equal to 6, the last index, are assuming right size is equal to 6, last index is size minus 1. That is this 5. Suppose size is 6, last index is this one. This 5 is nothing but size minus 1. Now one element is deleted, so clearly the last index will be this 4, right? 4, this is nothing but size minus 2. This is size minus 2. So that's what here control the value of j. For example, j is equal to position up to size minus 2. Here write A of j is equal to A of j plus 1 within the brackets. Clear?
Yes, sir.
Okay. We discuss in the next session. Thank you very much.
Thank you, sir.